On the Build Show today, we're going to be checking out a lecture from Steve Baczek called The Language of Architecture. This is probably something you've never heard about before, and special thanks to our friends at Building Science Corporation for sharing this video. This is actually on their YouTube channel as well. This is an invite-only building science nerd convention they've been putting on for many, many decades, training the trainer, so to speak. Grab the popcorn, grab a soda, and sit down. This is going to be a fabulous lecture by our friend Steve Baczek. Let's get going.
Again, please give Steve Baczek a warm welcome and take it away, Steve.
Thank you. So first and foremost, thank you, Joe and Betsy. It's an absolute privilege to stand up here in front of you, and thank you to all of you for, I know probably half of you in this crowd have, been behind and me pushing me along. You might not have known it, but you have been. And for those of you that don't know, I do know Joe for a long time. I was the first employee at Building Science Corporation back in 1996. And part of what I'm going to show you and talk about today, I will give credit to Joe in a huge way. He might not even know it, but when I graduated college, went to work as a traditional architect, you sit there and some guy hands you a detail and says, draw this. You don't get any instruction, you don't get any talk about it. It's a series of lines that you just have to replicate in the CAD program. So when you take a job for Joe, and remember Building Science Corporation was in its infancy then, so Joe's getting all these jobs, getting all these reports to write and stuff, so he does a little doodle on a napkin and says, well, we need to do flashing here, and I need a drawing here and here. Well, here, you just go figure it out. And it's like, okay, well, in hindsight, I was kind of had to go figure it out, but it was really giving me a new way to think as an architect. And it's a new way in such that architecture schools don't really teach those conversations that Joe and I had. And those are probably the most important conversations an architect could have. And it's still lingering because the second privilege I have is both my daughter and my son have gone to architecture school and graduated and work with me. And there's no higher privilege than for your kids to sit there and say, I want to be like you, Dad. So thank you to them too. So Joe said, hey, do you want to speak at summer camp? And I just walked away going, hey, I get to speak at summer camp. And then 10 minutes later it set in, shit, I got to speak at summer camp in front of this. So what are we going to talk about? So talk about the thing I know the best, drawing. And it's not so much, I'm not going to show you details and we're going to pick apart the details. We're going to talk about the concept of transferring information, the language of drawings. And for those of you that don't know, it is actually considered a language. I had a friend that went for a master's degree and they were able to use architecture in their college application as a second language because it's a graphic language. So, I've been doing this a long time, 44 years. The drawing to the left, I actually dug it out. It's the first wall section I ever drew in college, 1991. Come a long way because the rendering of the house on the right is the stuff I get to play with on days like this. Our firm, we work all over the country. We have projects in a lot of states from Colorado to South Dakota to Louisiana. Been doing it a long time, and I'm somewhat of a loyalist in the sense that the gentleman in the bottom right photo was my drafting teacher. And we usually get together a couple times a year and have dinner to just catch up and talk about, where life has taken both of us. Onward. Drawing. In developing this, I actually learned a lot about what I do when I set up a set of drawings. So a lot of things we just take for granted in our work until you're asked to explain exactly what you do. So one of the things that I was doing, I'm sitting there going, I wonder how many lines in a typical drawing set. So I opened up 3 random sets, listed it. So what you're seeing there between 40 and 70,000 is how many lines are in a typical drawing set. So when you're flipping through those sheets, that's what we're talking about, somewhere 50, 60,000 lines. And the reality is every one of those lines means something or should mean something, right? So we have a really important job in what we do. Although I have seen some sets where some lines probably didn't mean as much as they should have. But anyways, that's what we should strive for. Another thing that I always have to remind myself of, we might design a project for over a year, do CDs, get into it, and then we pass off the drawings to the general contractor and subs and code officials, and that's the first time that they ever see those drawings, right? So it's really important. For me, it's easy to sit there and say, well, you know, I know this is that, and that's on sheet A21 and this and that. But for someone to first see those drawings, right, there's a huge communication gap there until they get familiar with them. And some of them only need to get familiar to throw a bid at it or throw a number at it, et cetera. But it's really important that our set of drawings are compiled in such a way that if you're giving them to somebody that's not familiar with the project, can they comprehend it? Can they get, you know, behind it? So just some thoughts. This is a detail, not my detail. I should have made it larger, but I didn't want to make a big thing out of it. I just grabbed it off the internet. You know, it's one of those things that knowledge and wisdom, knowing what to draw versus why to draw it. There's a lot of architecture sets that I see get put together, and it's kind of like, let me see how many sheets I can fill up. Let me see how much random information I can pack in there for the builder to have to sift through to actually get the 2 or 3 tidbits of information that they need to actually use, as well as drawing the right thing. So when you look at that detail, notice there's a sealant bead under the head casing. Behind that sealant bead is a whole series of flashing. So from a building science perspective, we put in all this flashing to maneuver water only to dam it up with that sealant bead. So it's really not a detail that's functional or that would work, right? So knowledge is saying, hey, we should put something in here to keep the water out, while I say wisdom is asking the question, this does come from Joe, is asking the question, what am I sealing in? Buildings don't fail because you kept the water out. That's a successful building. Buildings fail because you kept the water in most of the time. So we have to ask the right questions when we're putting this stuff together. These I just threw in some random alternatives. While we do construction drawings, a lot of times we do drawings for, you know, different medias, prints, etc., some technical stuff. Peter Yost and I have done a bunch of technical books for different companies. And, you know, sometimes it's a 3D drawing, sometimes it's information that's highly focused that we're trying to get on, and sometimes we're just making it look pretty by putting it in color. As I develop details, one of the feedback that I get from the builders that I work with is they like the idea that the details I draw are recognizable, right? What does that mean, recognizable? It means that I'm not asking them to go and buy some out of this world material and tape it with this specialized tape that is extremely expensive. It's doing the right thing with the things that we already do. Most of the projects, most of the details that we develop, they're using the same tools, they're using the same techniques. We're just asking for a more conscious effort in certain ways that we do things. So when I look at a detail and I'm developing them on a computer, the 3 things that are important to me: recognizable, which we touched on; functional, it has to work, right? We don't want to put a bead of sealant downstream of a whole bunch of flashing. And it has to be executable, right? We all hear the stories of builders, oh yeah, those drawings just went in the circular file, right? Because they're a set of drawings that really didn't send a message of, you can build this. You know, one of the things that I pride myself on is the set of drawings, when they leave the office, there's at least one way that house can get built. Now, the framer might come back and say, hey, I like that detail, I appreciate it, but if we did this and this up on the roof, I think it would work a little better, and I'm more familiar with that. That's fine, But the drawings don't go out unless there's at least one road to success. They never go out and say, well, we can just figure that out in the field. No, that doesn't work. And it certainly doesn't work well. So, recognizable. So, at first glance, it's a relatively complex detail, but it really isn't. It's a double wall assembly outside a timber frame for a passive house structure. And it's got a SIPS roof. Everything there, most builders have touched or used in a typical house. We're just putting it together in a different fashion, maybe a little more complex fashion, but it's recognizable, right? There's nothing about that detail that says, hey, you have to go get this special tool or you're gonna need 3 guys to do that. It's stuff that they recognize that we can do. And that's part of that execution, right? If I give them something they understand, then it's something that aids in that execution. Functional, right? Has to work. This is a house that we did where slab on grade, we insulated on top. So it's got the 4 inches of insulation, 2 layers of Advantech in opposing directions going on there, making basically a 3,500 square foot raft in this house. But one of the things, and another quote I learned from Joe, it's better to be lucky than good, and doing this detail, when it came to actually drawing the slider detail, I said, hey, that top layer of Advantech, we can just hold that back 7 inches, and I have a sill pan under every door, right? So it's looking at that system to understand how does that system that I'm imposing on the builder work for the project and put the project in a position to succeed. Executable. I do a lot of work with Jake Bruton down in Missouri. This is a detail that we developed, right? We wanted to do a slab that is a finished slab, but we wanted to be able to insulate it. And it always becomes somewhat of a hassle trying to get the insulation in there and get the wall at the right place. So we came up with this 3-step method where we dug the trench, which is highly financially efficient there. They just a 16-inch bucket, they trace around the foundation line, they are allowed to ground form their concrete. So we did that, but notice the little curb. We put some rebar and then we pour the curb, but the curb is set in 2 inches. Why is it set in 2 inches? So that the concrete guy has a place to put the formwork. He sets it down on that lower piece of concrete and then basically pours the curb up against it, and then we do the slab and it's business as usual. But it makes that detail far more executable with that simple fact of moving that curb in 2 inches and making people's life easy. Let's talk about details in general and how I develop them. Well, first and foremost, we have to think about the things that hold it up, right? Obviously, we don't want our buildings falling down. So that's pretty easy. Develop the detail, put in the structure, how things are going to meet, and then how to make attachments. I chose this detail. I'm actually in the process of developing this one, so this is kind of like almost live streaming this detail. But we have 4 inches of rigid insulation on the outside of the wall, 6 inches on the roof. And how do we attach that? And better yet, attaching it is pretty easy. How do we attach all the trim around the windows and all of the associated pieces that come together with that? And do I have a place to nail that jamb trim or that head casing? All of these things make it executable, right? We have to think through these things. So before I even get into putting in tape and flashing and all of that, I want to make sure that all of my attachment requirements have been serviced here. And then I'll add the performance, basically putting in that insulation and the hatch and all of that. And then we'll simply add the text. You know, the other thing I find pretty common in construction drawings is you always get the real simple wall section or the real simple building section. Nobody draws the hard one, but the hard one is the one we need. The easy one isn't the one we need. The builder probably knows how to do that in his sleep. But when this roof is coming in and has to miss this window and then the insulation and the air barrier is in conflict there. Somebody has to sort that out and figure it out. And that's what we have to do. And we have to pick those hard details, not necessarily those easy ones. So, details themselves. You know, when I was developing this, I was thinking about it, and it's like, in all actuality, details are bilingual, right? We always think, hey, okay, there's a 2x6, that's an LVL, et cetera, but the people in this room tend to think of it a little differently. Like, where does the water go? How does this detail handle air management? How does this detail dry out? How is this detail insulated? What's the thermal management that's happening in here? So details aren't only about how do we put it together, it's also about what is that system doing with the other assemblies to make it a successful house. A lot of times I do what we're called our twins. So on a computer, it's real easy. I can do a detail, I can add all kinds of information, I can put it on separate layers, and I can freeze layers when we go to plot it. So you can see layers, 1 through 7 and 12 and 13. And then on a different detail, we can show layers 7, 8, and 9. And what that does is it allows me to sift and sort out information for clarity. Working all over the country, I obviously don't get to work with the same builders all the time. And in some places in America, the subcontractors, there's communication issues of trying to talk to them and or maybe just talking to one person on that crew who disperses all the information. But trying to find a way in which the drawings can kind of service everybody and sort out the information that that person needs at that particular time in the project, right? So this one here, we get all the notes in one detail, we get all the dimensions on the other side. So if the builder said, oh, I wonder what this is or what's this supposed to be here, he's not guessing, he doesn't have to call me, he's got a full drawing there with every applicable dimension to that detail. And so he can check himself and find out, okay, are we in alignment or not? And sometimes I do the twins, again, for the purpose of, we have different people doing different things. Probably, late 80s, I actually worked as a carpenter. Well, the guy that I worked for, they did the foundation. He did the framing, put the windows in, did the siding, did the roofing, and then put all the insulation in. Then the drywaller came in, and then he trimmed it out, hung the doors, put the cabinets in, put the hardwood floor down, right? Everything that I just said was 3 different contractors. If you did that today, we probably have 3 or 4 contractors that deal with the window, right? There's the guy that puts it in, then the guy that comes around and seals it and tapes it, and then the trim guy that comes around and puts the trim on. Totally different unions. Right? So how do we satisfy that? And how do we make sure that we're making their job as easy as possible, right? Without trying to make my job. I mean, I'm not sitting here saying, hey, let's double the price on doing these drawings. That's not my point. But trying to get this out so that we have as little conflict in that communication stream as that we can. Right? So again, twins, the detail on the left, that's for the framer. It's everything the framer needs to know. It's all of the framing components. It's where all the beads of sealant and everything that he has to do is on that detail. The detail on the right, while it still shows all of the beads of sealant, it only has the notes for the trim carpenter. It's how do I put the soffit in, the fascia, all of that. So we're able to separate that information so basically each of the subs get their own version of that detail rather than having to sort it out. So, like being here talking to you today, fear is a really good motivator. Got this project on the coast north of Boston, drove away going, yeah, brand new, beautiful, big house right on the rocky cliff overlooking the ocean. 10 minutes later, holy crap. Big house, very rich client, house on the ocean. on a rocky cliff. Maybe it's, you know, careful what you wish for, right? Those cliches, they do mean something. But anyways, so we're doing this. Rocky cliff, we do a bunch of blasting, bunch of grinding. You see the foundation plan on the left. Foundation has probably in total somewhere around 27 or 28 different elevations, right? Bottom of footing, top of wall, wall drops down 2 feet, goes 4 feet, drops down 2 feet. And it had to be tied into the surveyed plan because the town or jurisdiction we were in, this was extremely tight. We were putting a house literally on a cliff looking at the ocean. That was where the old house was. So there was no maneuvering for that's kind of close. No, it had to be. And so that fear really started to instill some fear. So the blow up on the right, you can see, that's that colored section in the lower left of the plan. The places where I highlighted, notice I mark up steps in wall, step in footings. It even has the finished grade at every corner of the building in parentheses. And I thought, okay, I have that dialed in, but when I look at that, I still don't see the full picture. And if I don't see the full picture and I send it out to somebody and it's the first time they see it, how can I expect them to see the full picture? Right? And so there are some pictures. You can see the site, top left, bottom right, footings and stuff going in. As a side note, I always separate a lot of drawings. I'll pull the foundation wall out and put it on the foundation print. I'll pull it out of the wall sections. That way there, two things are happening there. And I learned this from conversations with builders. They don't want to have to send 5 or 6 drawings to their concrete guy. They want to send 2 guys. So if I put a section of the foundation wall on the foundation drawings, they can just send that one drawing off, and now the foundation guy has everything he needs to know on one sheet, right? And you're not taking a bunch of sheets, and he's not sifting through wall sections, throwing siding and all of this other stuff that really doesn't pertain to him. He's long gone before the lumber gets dropped, right? So what did I do? I built the 3D model of the whole foundation. It added a few hours, but this isn't a cheap house. And to fix that problem is not a cheap fix, right? So a couple hours, maybe we're talking 6, 7 hours to get it perfectly right was certainly worth it. Notice in the model, you can barely see it, but there's some green fading. So I was able to delineate between above grade and below grade. So in doing that, I solved the problem for, okay, I understand what I'm doing now. I see it here in 3D. How do I get this to the builder? So I take that drawing, I add a bunch of dimensions, and here you can clearly see all of the numbers in green tied directly to the site plan. So now the builder knows exactly where the insulator goes. So what does Brian do, who's the project manager here? Well, he takes my numbers, goes around the foundation, snaps a bunch of lines, sprays that green line in the photo, and then simply tells the gentleman coming to do the tough and dry, just take it up to the green line. So I'm out of hot water, the general contractor's out of hot water, the tough and dry guy is out of hot water, and the excavator is out of hot water, because the excavator now just bury the tough and dry. So that one drawing coordinated a whole bunch of efforts, but not only coordinated, but lowered our risk to almost 0 for 6 hours worth of work. One of the other things that we do, especially with local projects, the projects away from here, they become a little bit of a challenge. But locally, I have a structural engineer. He doesn't do any of the drawings. We draw every structural drawing, details, sections, framing plans. I send them to him, he marks them up, I put the marks in, I send them back, he signs off on it, I stamp them, we build the house. Now, you might sit there and say, well, Steve, that's a lot of work. It is, it's a fair amount of work, but he doesn't charge much. He'll do a $4 million house for a $2,500 structural fee, right, to review the drawings, because I'm doing all the drawings. But the beauty is, by me doing the structural drawings, I don't know many structural engineers that go beyond strength or holding up the building in the detail, right? Not many structural engineers, and it's not a dig on them, it's just they're not trained to see that way, right? So by me doing all of the details, then I can sit there and say, where does the water go? What happens to the water? So this is a very small detail on the house, but we did these joist hangers that were welded to that 3x5 on this deck. And then I called out for the backside of the joist hanger to be notched so water could drain out. So that floor joist doesn't sit in a puddle of water on that joist. We know where the water goes. And the floor joist sits on a little 1/4-inch piece of neoprene. So it never sits in water. A joist will never rot out. It has the ability to dry. Water has the ability to drain. We get a detail that holds the deck up, but it's highly durable now because I take the responsibility to coordinate the structural engineer's efforts with our building science efforts in that detail. Same here. If you follow me on social media, I'm sure you've seen this project. I put no less than 1,000 photos or videos up of it. You know, we were developing this project, Jake and I, he was the builder on this, and I said, it'd be really cool to do a 10-foot cantilever deck out here, or 8-1. It's probably a little over 9 foot, but send it to the structural engineer. He goes, yeah, we can do that pretty much no problem. I was like, yes, that's awesome. But the structural engineer comes back and he has these two 7-inch angles and he's got them welded together. And there's a little notch at the top. And I said, okay, from a durability perspective, where does the water go? Water's gonna go, it's gonna sit on the top of those angles, it's gonna rust out eventually, and this deck is gonna fail. So I went back to the structural engineer and said, can we split the angles? And you'll see it in between the angles. We welded a little 3/8-inch steel plate like every 3 feet along those angles. So now water can freely drop down in between those angles. Water management issue gone. We have a draining system that can get rid of the water. We've answered that question, where does the water go? And then these are just some other details for the steel guy, giving you a picture of it. Even the steel post on there, we put a little slope. It's an 8x8, and I called for a little 5% slope on the top, so that we're always stitching together building science with all of our work and asking the very simple questions. I always find it interesting, you know, I'll sit in on a Thursday, or I won't say Thursday, it didn't mean BS and beer reference, but I'll sit in on these online seminars and man, architects love to complicate shit. They'll put tons of insulation in and say, where does the water go? Oh, it's gonna get stuck in there. Oh, that no problem. We'll just drill through the insulation and provide a drainage path. $4 million house, and your answer is, we'll drill a hole up through the insulation where we're over insulating the window frame? Doesn't sound like a detail that would go appropriately with that house. But man, we love to complicate things. Building science is pretty simple. I use Joe's remark, and I know I reference him a lot, but pretty much Joe is a lot of the reason I'm standing here in front of you, right? It's not rocket science, it's building science. I tell people that all the time. You ask 10 simple questions and you lower your risk by half if you can answer them successfully in doing a set of drawings. It is that simple. It doesn't have to be complicated. Roof framing plan. A lot of times we don't draw things because we are actually designing them. I'm drawing them to show somebody the intent, right? We do a roof framing plan. The roof framing plan goes to the general contractor who sends it to his truss manufacturer. If I don't do the truss elevations, guess what? I'm almost guaranteed to get back a truss package that is nothing like what I intended, right? The heel height is wrong. The slope of the roof might be wrong. If it's a hybrid truss that has a small portion of scissor truss embedded into a gable truss, the dimensions are going to be wrong. So I learned early on, if I simply draw a couple truss profiles and then I outline where they're located on the roof plan. Now it's a drafting exercise for the truss manufacturer. They don't have to think. All the dimensions are answered there. They can plug it in, they can send the drawings back, and we save a lot of time, right? It costs me a little bit of time to do it, but we save that time in not having to go back and forth 3 or 4 times and then have the truss still come out wrong. Now, some of you might laugh, but it happens, right? 3 or 4 iterations, they build them and they come out and we're cutting them up and modifying them on the site. Some focused information that goes on drawings. We do a lot of work on the water, near the coast. In this particular project here, I think we used, I think this was Zip R6 or maybe it was R9. In this particular case, this was Zip R9. The structural engineer, you know, he had a long list of, hey, we need to figure out a way where we can show them where the shear walls are, where connectors are, and then here's all the hardware that goes in the wall section. So we developed drawings that showed those answers. There's no other dimensions on those floor plans, nothing. It's just, this is where the shear walls are. You have a shear wall schedule there. We know how they're built, what nail goes in, what the spacing is on that nail. In the wall section on the left, we have the details. We have all of the Simpson hangers called out, where their location is, what their spacing is on that wall. Again, making everybody's job that much easier to be successful with. Windows. This is a big talk because windows are a tough one. We do a lot of Euro flangeless windows. Occasionally we do some flanged windows and we're working up some standard details for that, but I use the flangeless for this example. In my time, I've probably done about 9 generations of window details because I like to go out, I always install the first or second window with the builder. And I tell them, I don't do it because I'm coming out here and this is some kind of lecture like, hey, Jimmy and Johnny, pay attention because I'm going to show you how to do a window. No, we go through how I typically install it, ask them, do you have any conversation here, any discussion you want to talk about? Do you want to change something, do something? And occasionally they say, hey, maybe if you did this or can I do that? And then it becomes the next generation of the detail. But one of the problems with these details is you have the sill, jamb, and head, very traditional details, pretty highly detailed, all the dimensions, everything are there, but again, it's a whole bunch of information that different parties only need small tidbits for that, right? I could calculate the rough opening for the windows on here, but it'd be a hell of a challenge. And yes, we've had a house where we went out there and the builder framed every window opening 1.5 inches short in width. In height, it would have been easy, but think about it in width. Every header has to come out and get recut. You talk about a pain in the ass. Yeah. And especially when it's 1.5 inches, does that mean it's off center? Do we have to recenter it? So, needless to say, the days of 3 details for windows, long gone. Now, we get a whole series of details. We're just going to run through how that one sill detail became 9 details. All right? So detail 1, that's everything that has to happen to the rough opening. Right? We put a back dam in, we put a slope sill in, we put a piece of flashing. That's where our window is gonna go with the applicable dimensions. That's it. That's everything that the rough framer needs to know to install that window. And oh, by the way, I did a front elevation to show you where some shims will go and where the flashing goes on that detail. So that's 2. Detail 3, we install the window. We do our air sealing detail there, end of detail. Detail 4, trim carpenters come in, siding contractors come in, siding gets attached, trim, all of that stuff gets applied to the window, and then we move on. 4 details. But it doesn't stop there. When you get asked the same question for about 15 years, it kind of tends to say, maybe I should draw a detail that just answers that and everything else that's associated with that question. So this is a framing elevation. It's got every rough opening dimension, unit dimension, et cetera, in there. And how does the framer frame that rough opening? So now I don't get any more calls about, hey, Steve, how do we, like the rough opening, I just want to run those numbers by you. No, go to sheet 21, it's there. Unit dimension plus 2 inches wide, unit dimension plus 3.5 vertically. It's all there, no questions asked. It still doesn't stop there. I did it in section and plan. So we have the dimensions everywhere. Everything's labeled appropriately. The exterior sheathing is there. We'll have them for different details. But again, providing that level of clarity so that we can do something. We saw the, I forget, is Brian from RDH yesterday, right? Windows. It's one of the most susceptible areas in a building. But yet, how many drawing sets have we seen that actually have executable window details on it? Right? I mean, if I was an insurance company and an architecture firm came to me, I would be like, yeah, we'll give you insurance, but you got to show me you can draw a window detail before we give you that insurance policy, right? But, I mean, we in this room laugh and joke because it is kind of funny. But the reality is, you know, Peter Yost and I jump fences and go and look at these, you know, houses when we're traveling. It's horrendous. And we're not talking about some little 1,200-foot cottage. We're talking about a $6 million building somewhere in Texas. So it's you know, I'm serious. It's like, how many people really? And, you know, I tell a little short story here. I had a couple guys, consultants, you'll appreciate this, that they were the best Monday morning quarterbacks that I've ever met. So I got them one day. I said, you know what? We're going to install windows out at the Johnsons. Why don't you come on out and we can talk? So we got out there. Framer's getting things ready. I said, no, let's let these two guys install the window. And they looked at me and said, you want us to install the windows? I said, yeah, all the tools are right there, drawing details right there. You're always telling me about how I should do this and draw this. What a great opportunity for me to learn from such experts. We stood there for about an hour and a half before we said, guys, forget it, just go. And we installed the window. But it's a lot easier, you know, to talk about this stuff and create an academic exercise about this stuff than it is to do it. And unfortunately for me, I'm in the position where I have to do it, right? I have to provide details that someone's going to use next week and we're going to be installing windows. It's not a, hey, let's put that up and we'll talk about it, have a conversation. No, we have to do it, we have to do it right, and we have to make sure everybody is on board with it. So we're through 7, but it doesn't stop there. I get a lot of questions about, hey, where do the brackets go on holding the windows? So I did a drawing outlining the brackets, showing where they go, how close they can go into the corner, but not in the corner, 16 inches on center. And then the last detail is a simple detail to say, hey, here's how you flash a window. Now again, we can sit here and chuckle, but when we're in Colorado and the owner of the framing crew tells guy number 1 that we're going to install windows today, and guy number 1 tells guy number 2, hey, get guys 3 and 4 to get the windows out of the garage and get those installed, by the time it gets to them, we're making pumpkin pie or something in the back of the house, right? We're not installing windows anymore. So we have to make sure that you just hand them this stuff and say, this is how you flash a window. This is how you properly lap that flashing. This is the dimension I expect that sill flashing to go up the wall. Part of what we do as architects is we come up with ideas. Is Katrina in here? So I don't know if Katrina's in here, I don't see her, but anyway, she'll be happy to know. This is a passive house that we just recently did. Slab on grade, and of course, the HVAC guy, he's crying and moaning. I need space, where am I gonna put all this? All right, so I tell you what, I got an idea. We'll create a manufactured attic, and we'll throw it up. We'll have the truss guy do it, and we'll put it up there. So I developed the idea, drew up the section. But it's not good enough to just stop there. Because, yeah, okay, I illustrate the idea. Everybody in this room can look at that and say, great, but how do we do it? We're in the business of doing it, not talking about it. So, translated that idea to the roof plan. Hey, here is that area of raised soffit. It touches every room on the second floor. So now the HVAC guy is totally satisfied. He can get ductwork and our Zender ports to every room on the second floor. We don't stop there. We show the truss manufacturer. These are the two different trusses that we're going to use on that project. And this is what I intend to do to create that manufactured attic. And these are the dimensions that we want the trusses delivered at. And then we do the final detail where we put in the performance specs and the text and everything of how exactly that roof detail comes together and how we build that manufactured attic, right? So having an idea, we have to make sure as architects that we follow through with that idea, that we just don't whip up that one quick drawing and say, yeah, we'll figure that out. No, it needs to get figured out. And, you know, when clients say, well, why should I hire you? Well, you have many choices. The beauty of America is you got choices. You can have someone with 30 years of experience figure it out. We can send it out into the field, and guys 4 and 5 can figure out how to do it. What do you want to do? It's a pretty short conversation. Joe, you'll be happy to know the next generation of the perfect wall. I'm not leaving it up there that long because we haven't built it yet, but we will. And yes, the final comment on details. They should look good. You're putting your name out there. When they get out there and somebody opens it, they'll be like, damn, that is a set of drawings. Right? That's what you want to hear. Oh, you got jokes.
Those are the things I was told when I got lost in the weeds with details. And having worked as a draftsman and a designer, this level of detail scared folks because they figured it created a situation to where they were more liable by providing more information. And they would say, you're getting too lost in the weeds. They'll figure it out in the field. We're not here to tell them the means and methods.
So this detail doesn't show means and methods. Right? It's showing performance and components. And I've had that conversation with many builders, like, man, I mean, you got a lot of stuff here for us to sort out. You know, we just usually install the windows. Well, no, not today. Today we do it my way.
What was the question?
He was just saying that, you know, a lot of times people will say when you get to this level of detail, you're getting too deep in the weeds and you're actually providing more information for confusion and you're kind of working against yourself. Well, to that I say the best instruction manual is probably the best road to success. So they can say what they want. They don't want to take the time to figure it out. They're not the right builder for the job.
If for some reason you don't know Steve Baczek, go follow Steve on Instagram. He's posting every single day just about from all his fabulous job sites and from his studio. And if you happen to be an architect watching this, he's one of the only architects I've ever seen that's willing to grab a camera and show his exact details, walk you through how he came up with that detail. He's got a character now on his show called Big Red, which is a Sharpie pen. He actually runs through all the details. This is a fabulous man who's educating the world on how to build a really good house. Go check him out at thebuildshow.com. There's a hamburger menu at the top. When you drop down, look for Steve Baczek and check out his videos. He's one of the OG Build Show contributor, so he's been around a long time. He's got a lot of videos for you to catch up on. With that being said, guys, hit that subscribe button below. We've got new content every Tuesday and every Friday. Follow us on Facebook or Instagram. Otherwise, we'll see you next time on The Build Show.